Hello and welcome to this temporary traffic control update webinar. My name is Durwood Shepard. I'm the State Standard Plans Engineer within the State Railway Design Office, and I'll be covering the revisions to the fiscal year 2021-22 standard plans and the 2021 FDM. As you may have already noticed with the release of the 21-22 standard plans, these updates include a fairly significant redevelopment of the standard temporary traffic control applications included within the 102 series of standard plans indexes. Let me first start by explaining some of the reasons why the department has been making recent revisions to our temporary traffic control policy, standards, and specifications, and while we will continue to make needed changes to streamline current criteria and seek innovative solutions. The number one reason is safety. As of the latest national data on work zone safety, the state of Florida currently ranks second nationally in work zone fatalities. As a result, Florida has become a focus state for the Federal Highway Administration, and the issue has become an emphasis area in the department's strategic highway safety plan. Of note, between 2016 and 2017, work zone fatalities increased by 3%, while all other highway fatalities were decreasing. As an example, this table shows the number of work zone fatalities by year between 2009 and 2018. As outlined in the red column, the amount of work zone fatalities has increased since 2010. The second reason for revisions to the temporary traffic control policy and standard plans is to address issues with inadequate temporary traffic control plans. This issue is primarily a construction contract plans related issue and deals with contract plans not having sufficient or consistent details. However, there also tends to be a considerable amount of confusion between designers, inspectors, contractors, and maintenance personnel over their responsibilities, which can be attributed to redundant, misplaced, and contradictory information within the department's policy and contract documents, including the standard plans and standard specifications. Furthermore, there has also been an over-reliance and misapplication of the standard plans typical applications, along with issues of consistency between the typical applications included in the standard plans. Accommodating all users has historically also been an issue. Bike and ped accommodations have been left almost entirely up to the contractor to provide, and with little or no direction in the contract plans, proper accommodations are not being made. Finally, we also want to try and reduce the amount of construction-related claims and pay item overruns. Through more consistent, simplified, and streamlined temporary traffic control standards, the department aims to better communicate intent, avoid redundancy, and better impress upon all users that the temporary traffic control typical applications are rudimentary and likely require supplemental project-specific TTC plans and/or proper judgment from the worksite traffic supervisor to sufficiently execute temporary traffic control operations. As a general overview, I would like to take a few minutes to discuss some of the relevant governing documents pertaining to temporary traffic control operations on the state highway system. It's important to understand how these documents work together and how important it is to use these documents in combination with each other. Starting with the standard plans, the first set of indexes included are 102-100, 102-110, and 102-120, which provide information for temporary barriers. Then we have index 102-600, which includes the general information for traffic control through work zones and applies to all temporary traffic control operations on the state highway system, including but not limited to the standard TTC applications included within the remaining 102 series of indexes. That is, regardless of whether or not indexes 102-601 through 102-680 are used, the requirements of index 102-600 still apply. Furthermore, indexes 102-601 through 102-680 include rudimentary standard TTC applications which cover common yet basic typical traffic control operation details. These rudimentary details work well for simple construction and maintenance operations, but often have to be used in combination with one another or supplemented with more specific project TTC plans. Also of note is index 700-102, which is used to provide department-specific special sign details for temporary traffic control signs. And it should also be mentioned that within the standard plans for bridge construction, indexes 102-200 through 102-240 include details for temporary detour bridges. Next, we have the standard specifications, and as a subset, the maintenance specifications. These specifications include a wide range of contractual, operational, workmanship, payment, and material requirements. Like Index 102-600, Section 102 of the specifications control temporary traffic control operations for all projects on the state highway system, and the specifications must be used in combination with the standard plans to provide a complete set of department requirements. In addition to the standard plans and specification, there is the Manual on Uniform Traffic Control Devices, also known as the MUTCD, which includes the minimum requirements for all traffic control devices, i.e. signs, pavement marking, signals, and other traffic control. The MUTCD is the minimum national standard for all public roads and must be followed in accordance with the Code of Federal Regulations. Part 6 of the MUTCD provides the minimum requirements for temporary traffic control. While the standard plans and specifications have standardized and adopted many of the topics covered in the MUTCD, it is important to understand that some requirements are only found in the MUTCD. Finally, there is the FDOT Design Manual, also known as the FDM, which provides the department's design criteria for transportation management plans and temporary traffic control plans included in the contract documents. FDM chapters 240, 241, 242, and 243 also include requirements for items such as lane closure analysis, traffic pacing design, portable changeable message signs, detours, guidelines for non-motorist accommodations, and temporary traffic control pavement markings, to name a few. The FDM requirements are to be used in the development of all TMPs and temporary traffic control plans used on the state highway system. The FDM and temporary traffic control plans are typically not needed for normal maintenance operations. To highlight the importance of using all relevant documents, I wanted to provide a few examples of how the standard plans and specifications must be used together. The following examples are requirements only found in the specifications and include the MUTCD reference for conditions not addressed in the standard plans or contract plan, the requirements to maintain business and residential entrances, vehicle and equipment visibility requirements, requirements for traffic control officers, and traffic control device requirements such as crashworthiness, PCMS deployment, error board requirements, TMA test levels, retroreflective sign seating, and pavement marking placement and material requirements. Next, I would like to walk through some of the components of the changes and highlight some of the informational resources available to explain some of the primary changes that affected the entire 102 series of standard plans. The first resource I would like to mention is the review comments and responses included on the standard plans website. The review and response link on the standard plans webpage provides access to a complete list of all comments received during the standard plans, internal, industry, and FHWA reviews, along with a response from the FDOT Central Office technical experts. These documents provide great examples of commonly asked questions during the review process. Some of these common questions and comments will be addressed throughout this webinar. Also included in the review and response resources is a TTC Summary of Changes document. This summary document provides an overview of the changes made to each individual standard plans index in the 102 series. The last two resources I'd like to highlight are the revision log and crosswalk. Both of these documents are included to provide information about the revision history for each release of the standard plan, and a crosswalk can be provided to be used when indexes are consolidated, renamed, or renumbered. As an example, Index 102.605 has been consolidated with Index 102.604. The crosswalk provides a resource for cross-referencing this type of information. As previously mentioned, there are some overarching primary changes that occurred to the entire 102 series of indexes. These changes include consolidation of similar types of information to avoid redundancy in an effort to simplify and streamline the overall series. Removing redundancy helps to improve understanding of intent and avoids confusion, which can occur when requirements and details are stated differently in separate locations. Throughout the indexes, many of the redundant notes were removed, and in total, 12 indexes were consolidated. Consolidating information can help provide more consistency across the standard TTC applications. One substantial example of consolidation is the consolidating of channelizing device spacing, taper length, work zone sign spacing, and buffer length tables to index 102-600. These tables now consistently apply to all of the standard TTC applications included throughout the 102 series, and by placing the tables within the general requirements of index 102-600, they now apply to all conditions included within the standard TTC application. This screenshot from 102-602 for work on the shoulders illustrates an example of how sign spacing dimensions are now consistently applied throughout the 102 series. Another primary change was the removal of antiquated or complex standard TTC applications. These include crossover details, which are the responsibility of the contractor to determine their internal traffic control plan for their equipment and vehicle movement. Complex conversions or diversions, which would require site-specific TTC plans, and toll plaza operations, which are becoming antiquated with new tolling technologies. In total, 7 indexes were deleted. The final overarching change to the 102 series is the addition of standard plans instructions for the entire series. Standard plans instructions are documents used to communicate the basis and limitation of an individual or group of indexes. The information includes design criteria used to create the index or indexes, assumptions and limitations for the use of the details, requirements for plan content needed to properly communicate usage in the contract plan, pay items used for the compensation of the details, and any other pertinent background information or examples that can be used to help with the user's understanding or implementation of the index's details. Shown is an example of the new 102 series standard plans instruction. I would now like to take some time to further highlight some of the specific changes made to the standard plan and address some of the common questions we received during the review process. I previously mentioned the consolidation of device tables to index 102-600. However, I would like to take some time to show these tables in more detail. Table 1 covers channelizing device spacing and provides a consistent yet conservative standardization of the device spacing guidelines included in the MUTCD. It should be noted that if site-specific conditions or issues arise, the worksite traffic supervisor or the engineer has the ability to alter channelizing device spacings to best suit the needs of the operation. Table 2 covers taper length. This table provides equations for the determination of the proper taper length for variable L. However, it is important to understand the consistent application of taper lengths throughout the standard plan. As required by the MUTCD, taper lengths are detailed throughout the standard TTC applications as follows. The full value of L should be used for merging tapers. Shifting tapers use half the value of L, and shoulder tapers use a third of the value of L. One of the most significant consolidation efforts within the traffic control device tables involves Table 3, work zone sign spacing. These spacings are now indicated by variable X within the standard TTC application. These values will provide a consistent spacing for all temporary signs used within work zones and represent a standardization of the sign spacing guidelines included within the MUTCD. One exception is made in the footnote, which states that for limited access roadways with work zone speeds less than 55 miles per hour, the minimum sign spacing may be reduced in accordance with the MUTCD and as approved by the engineer. Table 4 provides buffer lengths indicated by variable B. These values remain unchanged from previous versions of the temporary traffic control standard. The footnote included on Table 4 states that when buffer lengths cannot be attained due to geometric constraints, the greatest length possible is to be used, but not less than 155 feet. This note was previously included in the general notes of various standard TTC applications, but was inconsistently applied. Through inclusion on index 102-600, the note now applies to all standard TTC applications. In an effort to provide a user-friendly version of the traffic control device tables, a quick reference sheet for the 102 series tables is available on the Standard Plans website at the link highlighted here. This quick reference sheet is provided in a standard 8.5 by 11 paper size format for easy printing as a reference guide by field personnel on a construction or maintenance job site. Table 2 on the quick reference sheet includes the addition of example L values. As shown, these example L values are provided for common widths and work zone speeds, which range from 25 to 65 miles per hour and widths of 5, 10, and 12 feet to represent common paved shoulder and lane widths. It should be noted that these example values are provided to aid in common applications. However, for speeds or widths not provided, the equation should be used to determine the appropriate value of L. The duration notes included in the previous standard plans provided operational time limits for conditions where various work zone traffic control devices may be emitted. However, it's important to understand that many of these duration notes have become outdated based on current requirements within the standard specifications, or they don't represent the department's current philosophy on best practices for advance notice of work zones. For example, the standard specifications require all work vehicles and equipment within the work zone to have high intensity rotating, flashing, oscillating, or strobe lights in operation. Therefore, the usage of such devices no longer provides sufficient justification for emitting work zone traffic control devices. Likewise, road work ahead signs are now no longer considered optional based on duration. The previous condition notes basically describe the details shown in the standard TTC application. However, these notes are considered redundant to the details and unnecessary, as the details in each index clearly illustrate the appropriate layout for the application included. Where appropriate, the revised indexes now have general notes stating the intended usage for the application. For example, General Note 1 on Index 102602 reads, "This index applies to two-lane, two-way, and multi-lane roadways, including medians of divided roadways with work on the shoulder." The general notes throughout the 102 series have also been revised for consistency and to avoid redundancy. In many cases, the general notes of the previous standard plans were carried forward, but were updated for plain language and to clarify intent. However, a number of redundant notes, or what I refer to as cross-referencing, have been removed. As an example, the screenshot on the right has highlighted notes removed from the previous index 102603. These notes cross-reference requirements included in other indexes or the specifications, but are not all-inclusive. Having cross-referencing notes within the standard plans, which address some but not all of the necessary requirements, misleads users to think that all of the relevant requirements are addressed within the individual index. As mentioned previously, one of the overarching concerns with the use of temporary traffic control standard plans is an over-reliance on the standards, in particular individual indexes, as standalone, all-encompassing policy document for the implementation of temporary traffic control operations. However, the standard TTC applications must be used in combination with the general information on Index 102-600 and the standard specifications, sometimes in combination with each other. Therefore, no cross-referencing of requirements is needed. This screenshot shows an example of the general notes included on the revised two-lane, two-way intersection work standard plan Index 102-604. Which illustrates the typical new general notes included within an individual index. Note 1 provides the appropriate application of the index similar to the previous condition note. Note 2 provides a specific reference to the variable X shown in the details for the work zone sign spacings table. And Note 8 replaces the previous duration note. All of the remaining notes cover requirements specific to the details in this index. The final overarching change I would like to cover is the depiction of shoulders and the use of shoulder closed signs throughout the 102 series standard TTC applications. As shown here in the new detail for a two-lane, two-way diversion, we now depict shoulders along the roadway and a continuation of those shoulders through the work zone. Maintaining shoulders through the work zone has historically been a part of our design requirements for temporary traffic control plans However, shoulders were not previously specifically depicted within the temporary traffic control standard plans. As with permanent conditions, providing shoulders through the work zone is a proven safety countermeasure for reducing crashes. The shoulder provides additional recoverable area for vehicles that depart their designated lanes. They help mitigate vehicles shying away from channelizing devices, and the shoulders also provide accommodation for non-motorists through the work zone. Both the FDM and standard specifications require that existing bicycle facilities must be maintained or detoured satisfactorily throughout the project limit. Additionally, on the state highway system, with the exception of limited access roadways, all paved shoulders 4 feet or wider are considered a bicycle facility. Therefore, if an existing non-limited access facility has paved shoulders of 4 feet or more, the shoulder width is to be maintained through the work zone. There are, however, certain roadway types and work operations where providing shoulder width is not practical. For example, a typical resurfacing project on a 2-lane, 2-way road using index 102602 for work within the traveled way. This configuration would not have sufficient space to provide a shoulder on both sides of the 1-lane condition. Therefore, for conditions where providing shoulder width offsets is not practical, a right shoulder closed sign has been added to the advanced work zone sign array. As highlighted in the screenshot shown here from index 102602, the addition of the shoulder closed sign notifies motorists and non-motorists alike that the right shoulder is not available through the work zone. The inclusion of shoulder closed signs within the standard TTC application does not absolve any responsible party for the requirement to provide non-motorist accommodations through the work zone. For short duration work, such as those common for maintenance operations, providing accommodations may not be practical or warranted. However, for long-term lane and shoulder closures, it may be appropriate to provide additional accommodation by means of a detour, diversion, or temporary path. For this reason, every index within the standard TTC applications that have potential for impacting an existing bicycle facility, the note highlighted here has been added. The note reads, if the work encroaches on a marked bicycle lane or rideable shoulder, close the lane or shoulder in accordance with the plans. This note is added to ensure that proper advanced consideration of bicycle accommodations is made during the planning and design phase prior to the execution of work operations. Rideable shoulder is referring to paved shoulders 4 feet or wider on non-limited access as mentioned previously. Additionally, a new bicycle lane closure standard planned index has been created to establish standardized temporary traffic control devices for the closure of marked bicycle lanes and rideable shoulders. More information on this new index will be provided later in the webinar. I will now walk through the 102 series and highlight some additional revisions made to the specific indexes. By and large, these additional changes cover topics not previously talked about. Starting with index 102600, the first change highlighted is one we have discussed previously, but I thought it would be good and helpful to show you what the consolidated traffic control device tables look like, which are now included on sheet 1 of the general information index. On sheet 2 of index 102600, there has been a revision to the temporary traffic control devices and pedestrian and bicycle notes. The temporary traffic control devices note has been updated to address the storage of traffic control devices when they are not in use. The pedestrian and bicycles note was removed from index 102600, and the information was consolidated with the bicycle and pedestrian accommodation requirements within standard specifications section 102. The temporary traffic control devices note now includes the following additions. Do not store temporary traffic control devices on the shoulder, sidewalk, or other roadway facility not affected by the work when the work is suspended. This additional note was added to address issues with storage of temporary traffic control devices outside of the traveled way when staging for future deployment or when work is temporarily suspended. Devices stored on the shoulder, sidewalk, or other usable facility may eliminate existing accommodations for motorists and non-motorists alike, which is not acceptable. On sheet 3 of index 102600, a footnote has been added to the clear zone widths table. And there's a minor revision to the lane widths note and the notes for regulatory speeds and work zones have been revised to add a new detail for speed reduction signing. The new footnote on the clear zone widths table reads, for temporary conditions where existing curb has been removed but not reconstructed, curb and gutter values may be used. This note was added to address locations where the original and final conditions include curb. However, a temporary condition with no curb may exist. For this condition, it is often not practical to adjust the clear zone width requirements for the temporary condition. The lane width note had a minor revision that changed the term freeways to limited access roadways, which is a more commonly used term within the standard plans and specifications. The final change on sheet 3 of Index 102-600 includes revisions to the notes for regulatory speeds and work zones. The previous notes included a mixture of direction to the designers and the contractor. The notes included requirements for designers to determine the regulatory speed during the development of the temporary traffic control plan, guidance on the placement of additional speed reduction signing, and direction to the contractor when they believed that field conditions warranted speed reductions different from those included in the temporary traffic control plan. The revised details on sheet 3 now only include the details and notes necessary to install speed reduction signing. Criteria and guidelines for the establishment of regulatory speeds and work zones as determined by the designer are now included solely in FDM Chapter 240. Since the standard plans are a construction document and the FDM is a design criteria document, it is more appropriate for criteria for establishing regulatory speeds to be located in the FDM. Direction to the contractor for the requirements of submitting a speed reduction warrant have been moved to standard specification 102. On sheet 7 of Index 102-600, the notes for removing pavement markings have been deleted as the notes were redundant to the conflict pavement marking requirements included in subarticle 102 5.8 of the standard specification. Additionally, the notes for signals was revised to remove the maintenance requirements for existing traffic signals because the notes are redundant to subarticle 102 9.15 and 102 9.16 of the standard specification. Finally, the notes for portable changeable message signs were also deleted as the information is redundant to or consolidated with the FDM and standard specifications. Sheet 11 includes the final change to Index 102-600, which now includes an added detail for RPM placement on multi-lane roadways. This detail was added to clarify RPM placement for conditions other than a 2-lane roadway. I would also like to point out that RPM placement in work zones are installed as a supplement to temporary pavement markings. If temporary pavement markings are not required, then RPMs would also not be required. Now we will start to cover changes to the remaining indexes in the 102 series and cover specific standard TTC applications. As stated previously, these standard TTC applications are rudimentary operational layouts of temporary traffic control devices. They are intended to provide solutions for basic operations and establish standard placement details for various configurations of temporary signs, channelizing devices, pavement markings, and other work zone related traffic control devices. These standard TTC applications often have to be used in combination, supplemented by additional contract plan details and notes, or superseded by project-specific details for complex traffic control operations. As we move through the remaining indexes in the 102 series, we will only be covering specific content changes that affect the individual index. The overarching changes covered previously in this webinar, that is sign spacing, device tables, and removal of redundant notes, will not be covered index by index. The first index in the series I'm going to cover is Index 102-100. This index covers general temporary barrier requirements, which apply to all temporary barriers with the exception of low-profile barriers. However, does include Type K barrier and any of the alternative temporary barriers available on the approved products list. While this index does not specifically cover any complete operational layout, it does provide standard layout information for temporary barriers. As such, previous Index 102-642, which covered transitions for temporary concrete barrier on freeway facilities, was consolidated into Index 102-100. As can be seen in the revised index on sheet 4, the delineation requirements for approach ends of temporary barrier have been added and include a simplified version of the details previously shown on old index 102-642. Index 102-601 is the first in the series covering operational applications and covers work beyond the shoulder. The primary changes to this index included consolidation with old index 102-611 and retitling the index 2-lane and multi-lane roadway work beyond the shoulder. Both index 102-601 and 102-611 cover the exact same applications with virtually the same notes and details. Therefore, the applications have been consolidated for simplification and to avoid redundancy. Like index 102-601, the operational details for work on the shoulder are very similar for both 2-lane and multi-lane roadways. Therefore, indexes 102-602 and index 102-612 have been consolidated into a 2-lane and multi-lane work on the shoulder index. There's also an additional scenario that has been added to index 102-602, which covers shoulder work less than 2 feet from the traveled way for work zone speeds 45 miles per hour or less. Previously, if work was within 2 feet, the only alternative was to close the lane. This additional application will provide some additional flexibility for low-speed roadways, but does require a lane width reduction to 10 feet. We will now move to index 102-603, 2-lane, 2-way work within the travel way. This index covers a lane closure of a 2-lane, 2-way roadway using flaggers. The primary changes within this index was the consolidation of the with and without details for temporary raised rumble strips into a single detail located on sheet 1. The conditions for which raised rumble strips are required has not changed. That is, for posted speeds 55 miles per hour or greater and work durations greater than 60 minutes. However, for simplification, one detail is provided illustrating a with temporary rumble strips condition, and note number 4 directs the user to eliminate the rumble strips ahead sign and associated sign spacing when they are not in use. The next index we'll cover is 102-604. This index covers 2-lane, 2-way intersection work and is a consolidation of old indexes 102-604 and 102-605, which address work near or within intersections. These details remain relatively unchanged. However, there are a couple revisions to address side street signage to make the details more consistent with the MUTCD. As can be seen on sheet 1 of the new index, which covers work near an intersection, side street sign details have been added to address appropriate advanced warning and operational controls. The new signs included are the roadwork ahead, in roadwork, stop signs, and a restricted turning movement sign. These new signs have been added to clarify that flaggers should not be used to control multiple directions of travel, which would be a violation of the flagging procedures outlined in the MUTCD. That is, the flagger must always be facing the road user for which they are controlling. That would not be possible if the flagger is trying to control road users from side roads and the mainline roadway at the same time. Likewise, the details shown on sheet 2 for work in an intersection have also been updated to include a flagger for each leg of the intersection for which the work zone is located. Again, this change is made to ensure that the flagging operations can be performed in accordance with the procedures outlined in the MUTCD. Next, we will take a look at index 102-606 for a 2-lane roadway lane closure using temporary traffic control signals. Revisions to this index include the addition of temporary raised rumble strips and associated signing, and the elimination of separate details for bridges and side roads. Also of note, haul road details have been removed and added to a new index, which will be covered later in this webinar. Highlighted here on sheet 1 are the additional temporary raised rumble strip details and a new intersecting side street detail. The temporary raised rumble strip details were added to ensure proper location of the devices and associated signage in relation to other advanced work zone signs. The side road intersecting the work zone detail, which provides a flagger control configuration for side roads, was added to provide a simple operational solution for side roads within the lane closure. As you may recall, the previous index provided details for intersecting side roads, which utilized a combination of temporary signals and flaggers. However, those details would require a complete signalization plan for proper implementation and successful operation. While similar layouts would be a reasonable approach, they should be implemented with a project-specific TTC plan. The short bridges detail was also deleted from the previous index. Locating temporary traffic control devices at a bridge, regardless of length, is no different than determining site-specific layouts for other conditions. For example, when lane closures fall near tight horizontal curves, existing structures prevent placing signs in the ideal location, or tapers are extended to account for sight distance issues. Every TTC application is unique, and the standard plans cannot address all possible scenarios. We will now review the changes to Index 102.607. The revisions include the consolidation of two-lane, two-way, and multi-lane mobile operations into a single index. Sheet 1, shown here, provides the general notes and operational details for two-lane work. Additionally, the general notes and details have been simplified to avoid confusion with the previous options for shadow vehicle placement and to provide a more consistent execution of mobile operations. The previous index had ranges and distance between work, shadow, and advanced warning vehicles. However, those have been removed, and Note 5 now directs the user to minimize the longitudinal space between vehicles to deter road users from driving between. Sheet 2 of Index 102.607 includes the multi-lane mobile operation detail. Index 102.608 covers two-lane, two-way temporary diversions. As can be seen, there are no significant changes to this index otherwise than the overarching revisions mentioned previously. For example, simplified notes, sign spacing consistency, and illustrating shoulders through the work zone. It should be noted that diversions often require speed reduction sign to be added. If applicable, the new reduced sign spacing details on sheet 3 of Index 102.600 should be used. I would also like to point out and remind you that applications such as this require project-specific TTC plan to detail the geometric configuration of the diversion. Depending on the project-specific requirements, additional temporary traffic control devices may be needed. For example, temporary barriers or additional channelizing devices if the work area is within the clear zone of the diversion's traveled way. The next index in the 102 series we'll cover is Index 102.613, multi-lane roadway lane closures. This index now includes a consolidation of all multi-lane lane closure standard TTC applications previously included within indexes 102.613, 102.614, 102.623, and the motorist awareness system details from Index 102.670. Sheet 1 includes the general notes and single lane closure details. Sheet 2 includes the double lane closure details. Sheet 3 has the triple lane closure details. And Sheet 4 contains the details for a lane shift utilizing the paved shoulder as part of the temporary traveled way. These lane shift details have been updated for consistency with the other standard TTC applications, which includes items such as temporary striping, sign placement, and application of tape rolling. Another revision that should be mentioned is the removal of the center lane closure standard TTC application from the previous version of Index 102.614. While center lane closures are an option in the MUTCD with typical application TA38, this is not a preferred option for the department. Therefore, the application has been deleted as an FDOT standard TTC application. Finally, for Index 102.613 is the addition of the Motorist Awareness System details, also known as MOS, from old Index 102.670. These details were simplified and added to the new Index 102.613 because the MOS is only used with multi-lane roadway lane closures and could only be used as part of the now consolidated options included herein. As seen here, the details now simply show how the portable changeable message sign, portable regulatory sign, and radar display unit fit within the standard advanced work zone signage. The appropriate signing and channelization layout would then continue after the applicable W20 sign. The next index we will cover is 102.615, multi-lane roadway intersection work. As with the two-lane, two-way intersection work, all of the multi-lane intersection standard TTC applications have been consolidated, which include indexes 102.616, 102.617, and 102.618. All of the scenarios previously covered in these indexes are now included within index 102.615. There are, however, a few minor revisions to the previous details that I would like to highlight. The first is the addition of Type 3 barricades in advance of the work zone as shown on Sheet 1 for work in the intersection. These barricades were not previously shown on the old Index 102.615 details, which was inconsistent with other standard TTC applications. We have also added a new Q-length reference and note on Sheet 3 for the application covering a left lane closure through an intersection where turning movements are allowed. As highlighted here, note number 2 now directs the users to provide sufficient queue length so that left turning vehicles do not block the remaining through lanes. This language is consistent with the guidance given in the MUTCD. The final revision to Index 102.615 is the application covering center lane closure shown on Sheet 4. This standard TTC application now calls for the use of a shadow vehicle and TMA within the buffer space in advance of the work zone. We will now cover multi-lane roadway diversions included within Index 102.620. As with the two-lane, two-way diversion details discussed earlier, multi-lane diversions also require project-specific TTC plans. Therefore, Index 102.620 has been simplified to communicate the basic requirements for signage and channelization. Sheet 1 shown here includes a generalized configuration of a divided roadway with no reduction in the number of lanes. I do want to point out that the details depict the use of temporary barrier to separate bidirectional traffic along the tangent portion of the diversion where the median separation is no longer provided. General note number 6, however, allows for a temporary lane separator to be used as an alternative for work zone speeds of 45 miles per hour or less. I would also like to again reiterate that site-specific diversion plans may require the use of additional temporary barrier or other temporary traffic control devices depending on the geometric layout and/or proximity of the temporary traveled way to the work area. Sheet 2 of Index 102.620 includes a diversion of an undivided roadway with a lane reduction in both directions. This detail is an adaptation of old Index 102.621. As highlighted here, the details for the undivided roadway diversion were revised slightly. A buffer space was added to the near side approach to the work area, and the channelizing device configuration on the right side of the detail was also updated for consistency with other standard TTC applications in the MUTCD. Index 102.625 covers temporary road closures. The details and notes were simplified for consistency with other standard TTC applications in the 102 series. Index 102.628 covers roadways with two-way left turn lanes. This index previously only covered the closure of the turn lane, which most often did not provide for a practical work area without encroaching into either one or both inside lanes. Therefore, the standard TTC application shown here on Sheet 1 was updated to include the closure of an inside lane to allow for an expanded work area. Additionally, General Note 4 allows for the closure of both inside lanes by duplicating the lane closure and merging signs, channelizing devices, taper, and arrow board in both directions. The index was also expanded to include new standard TTC applications that cover 3-lane sections. That is, a 2-lane, 2-way roadway with a 2-way left turn lane. The first application shown here on Sheet 2 provides for a 2-way flagger controlled operation. And Sheet 3 provides an application for the closure of one through lane and shifts traffic into the 2-way left turn lane. Both of these new standard TTC applications are limited to operations with durations of 24 hours or less and work zone speeds of 45 miles per hour or less. Next, we will take a look at the updated traffic pacing standard TTC application provided in Index 102.655. In accordance with the FDM and standard specifications, a traffic pacing plan is required for operation utilizing this index. As such, Index 102-655 was updated to include only the standard information needed to execute a traffic pacing operation in concert with the temporary traffic control plan. It should also be noted that the examples that were previously included on sheet 2 of the old index were moved to the standard plan's instructions provided along with the index on the standard plan's website. Since this information was intended to provide helpful guidance on how to initiate the operation and not the required procedure, the standard plan's instructions are a more appropriate location for the examples. The next index we'll cover is 102-660 for sidewalk closures. This index provides very basic requirements for the advanced sidewalk closure signing and traffic control devices needed for a pedestrian detour, a temporary pedestrian path, or a temporary diversion into the traveled way. Sheet 1 shown here includes the pedestrian detour. Sheet 2 provides the temporary pedestrian way detail and a new detail for temporary pedestrian diversion into the traveled way. This new detail is similar to the standard lane closure. However, a temporary barrier is added to provide separation and protection between the pedestrians and motorized traffic. Let us now take a look at a completely new index, 102-661 for bicycle lane closures. This new index provides standard TTC application for bicycle facility closures, similar to the options that we just covered for the sidewalk closures index. The applications shown are based on concepts provided for inclusion in the next version of the MUTCD. It is also important to note that the standard options included within the Index 102-661 are provided to complement the bicycle accommodation guidelines provided in the FDOT Design Manual, Chapter 240. Sheet 1 shown here provides the basic requirements for channelizing devices and signage for a bicycle detour. Again, keep in mind that the layout shown is very rudimentary. Proper consideration for the suitability of the bicycle facilities existing along the detour route are needed to ensure a safe and functional accommodation. The details illustrate a detour with a bicycle lane provided throughout. However, other suitable accommodations may also apply. For example, paved shoulders along the detour route. See FDM 240 for additional guidance. Similar to Index 102-660 for sidewalk closures, Sheet 2 of Index 102-661 provides details for a temporary bicycle diversion and for diverting bicycle facilities into the traveled way. However, the use of temporary barrier is not required to divert bicycle traffic into the traveled way, but rather channelizing devices are used to separate the temporary bicycle facility from traffic. I would also like to mention that the pay item and diversion surface material requirements for the bicycle accommodations included within Index 102-661 have been combined with the pedestrian detour requirements and included in the July 2021 standard specification. Also of note is the addition of work zone signs for bicycle accommodations. Because the MUTCD has not yet been updated to include all of the signs shown in the new Index 102-661, Index 700-102, which includes special sign details, have been updated to provide the associated signs. Next is Index 102-665, Limited Access Temporary Opening. This index was updated to simplify the notes and consolidate the controlling usage policy into the standard specifications section 102. And the final index we will cover is Index 102-680, Hall Road Crossing. As formerly mentioned, the Hall Road crossing details previously included within old Index 102-606 have been moved to a separate new index. This move was done to isolate this fairly unique situation into its own index. This will also allow the department to add another option for flagger-controlled haul roads in the future. There was one minor revision to this standard TTC application, which simply updated the distance between the stop bar and the haul road for consistency with the MUTCD. At this time, I would like to take a few minutes to highlight some temporary traffic control related revisions to the 2021 FDN. The first is the addition of a new Transportation Management Plan form. This form is now required for all projects, significant or not, to document compliance with the Code of Federal Regulations. which has specific requirements for developing transportation management plans, also referred to as TMPs. Oftentimes, the development of a TMP occurs through the project development and plans production process without being recognized as a formal TMP. The vast majority of department projects contain the required components, that is, a temporary traffic control plan, operational strategies, and public involvement. Therefore, this new TMP form will allow the department and consultants to document the activities already being performed as a transportation management plan. The form can be accessed within FDM Chapter 103. The next revisions occur in FDM Sections 240, 219, Detours, Diversions, and Lane Shifts. There are three primary changes to this section. The first is a simple reorganization that separated the criteria for designing detours and diversions and lane shifts from the definition. Secondly, clarification was added for the minimum shoulder width requirements to address non-motorized traffic. As mentioned previously, department policy requires that existing bicycle facilities be maintained through the work zone, and by definition, bicycle facilities include marked bicycle lanes and rideable shoulders, which include all paved shoulders with a width of 4 feet or greater on non-limited access roadways. Previously, only the absolute minimum shoulder width of 2 feet was stated in this section. Therefore, a 4-foot minimum width was added for non-limited access facilities with an existing paved shoulder width of 4 feet or greater to maintain bicycle facilities. The third and final change in this section was the addition of a reference to the FDOT Drainage Design Guide for guidance on addressing temporary drainage. FDM Section 240.219, which covers guidance for locating temporary pedestrian and bicycle routes, was also revised to clarify that temporary barrier is only used when diverting pedestrian traffic into the traveled way. Additionally, Section 242.1.9 was also updated to provide an appropriate reference to the Traffic Engineering Manual for the use of temporary mid-block crossings, as well as consideration for the use of temporary traffic signals or RRFBs. The last 2021 FDM revision we will cover is the temporary Acro Bridge section 240.2218. This revision was made to add a reference to the Acro Series 700 bridges for all limited access roadways and clarify that all temporary bridges require a project-specific foundation design. For additional information on the 700 series Acro bridges, please see the standard plans instructions for the new index 102.201 in the standard plans for bridge construction. At the time of recording this webinar, the July 2021 standard specifications are still in the development and review process. For the final version of the associated revisions discussed during this webinar, please refer to specification 102 once the July 2021 specifications have been published. This concludes the 2021 Temporary Traffic Control Changes webinar. If you have any questions, comments, or recommendations, please direct them to Durwood Shepard in the State Roadway Design Office and Olivia Townsend in the State Construction Office.